All right, hello. This is the Google Doc file that we have to finish and submit by the end of the week. So, I'm going to go through all the questions. You can of course skip whenever you want to skip and rewatch whatever you want to watch. But I'm just going to go in order, and I'm going to answer them all while talking through why I think that is the answer. So, you can listen to this if you want a bit of explanation, or if there's a question you haven't completed and didn't quite make sense at the time. For whatever reason, here we go. So, question number 1, this is for the first lesson, the first question. They want us to order those keywords, those 5 keywords in order. Cool. So, likelihood from 0 to 1, of course that's a half, and that's whatever in the middle. That first one, let me just change the color there. That first one is going to be 0, is going to be impossible. Impossible. Right. That middle one is going to be even chance, means not even change, even chance. Means it's 50-50. It could go either way. And 1 is also the same as 100%. So this is certainty. This is certain. It will 100% happen. Now let's talk about those in the middle. This one is closer to impossible, so we're going to say this is unlikely. It's less than 50% chance. It's not impossible. It's not something to count on. Which means this one becomes likely. It's higher than 50%. It's not 100%. So it's likely. There we go. Number 2. Use the keywords to label the events described below on the probability scale. Okay, so we have, again, 1, that's 0. I have something in the middle here, which is a half. I don't need those 4 scales because they're not evenly spaced, so don't worry about it. The chance of getting an even number when rolling a standard 6-sided die. Type dice. So, getting an even number on a die is 50% chance, right? Because there's 1, 2, 3, 4, 5, 6 different numbers you can get. 1, 2, 3, 4, 5, 6. Half of them are even numbers. 2, 4, and 6. That's 3 of the 6 sides. So that drops right in the middle. That's dice right there. Okay, that Thursday lies on the weekend. What's the chance of Thursday lying on the weekend? It simply never happens. I'm going to say Thurs. Oh, not a 1. At 0, Thurs. Right? So it's absolutely impossible. It's just, yeah. The chance of winning lotto, type lot. The chance of winning lotto is not impossible. People do it. It is very, very unlikely. So I'm going to put it very close to 0. So that box where it is really close to 0 but not quite, that'll be the lotto. The chance of rain in Auckland during winter. I think that's rather high. Winter in Auckland is a rainy season. It's not certain. It doesn't rain every day, and it's not a given. The probability of drawing either a spade, club, diamond, or heart from a pack of cards. Those are all 4 possible shapes. So, or suits if you want to be technical. Card. That is probably even more likely than the chance of rain during winter. Number 3. Change back to black. Number 3. use this spinner to complete the table below. So let's say we're spinning that, right? What is the chance of spinning the numbers in the boxes below? An odd number. Okay, I'm going to try to recreate that table to some degree. Fraction, decimal. Okay, cool. I have no space. I'm just going to do that. Right, there we go. And we have 1 question, 2 questions, 3 questions, and 4 questions. All right. The event of an odd number. In fractions, if you look at the spinner, there are two odd numbers, the 3 and the 5, and the chances seems to be 2 out of 4 possible places it can be. That's 2 over 4. You can also say that's a half. In decimal, that is, you can do 1 divided by 2, or you can put it in your calculator. Either way, you get 0.5. For percentage, you times that by 100 to get 50%. Okay, the chance of us getting a 2, I'm going to say that's 0, that's 0, and that's 0%. 2 is not on the spinner. A number less than 10. Now, all 4 numbers are less than 10, so the chance is going to be 1. Decimal is going to be 1. Percentage is going to be 100. Right. Last one, an even number less than 5. An even number less than 5. Now, we look at the possible numbers. An even number less than 5, there's only 1. That's the 4. So, the chance of getting the 4 on the spinner in fractions is 1 over 4. There are 4 possible outcomes. Getting 4 is one of them. That's a quarter. In decimal, that's 0.25. And in percentages, that is 25%. Moving on. Number 4. Use the bag of marbles to complete the table. Now, I'm going to read the question. Pete shakes the bag of marbles and picks one out without looking. So that's randomly just picking one out. What kind of marble is Pete most likely to pull out? So let's have a look. Let's have a look at the picture there. Which one is Pete most likely to pull out? We have 4 types, and we look at them. Which one is the most common? And I'm going to say it's white. Now, because it's random and Pete is not looking, the one where there are more of, the marble type there are more of, will be the one that Pete is more likely to take out. Okay, use probability to explain how you know. Now, we can use the explanation that I've just said, that there are more white than others. But since I am making this video, I might as well go and crunch some numbers. Okay, let's count up all the possible marbles there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marbles in the bag. How many striped marbles are there? Oh, that's not how you spell striped at all. Okay, striped. There is 1. Oh no, there are 2. There are 2. The chance is 2 over 12. 12 possible marbles in there. Striped, 2. What about spotty? There's only 1 in there. It's 1 over 12. I know I can simplify this to say it's 1 over 6, but just for now, let's leave it at this. We can simplify it later. What about white? How many are there? 1, 2, 3, 4, 5, 6. There are 6. 6 over 12. What about gray? 3 over 12. Now we can change this to decimals. We can change it to percentages, but we don't need to. We can already see that that is the biggest probability. 6 over 12. 50% chance of getting white. So there we go. That's question number 4. Now, second lesson. We are now studying 1B, listing outcomes. Question 1. Sony was asked to pick a letter at random from the word succeed. List all of the possible outcomes and the probability of choosing each outcome as a fraction. So there's an example there that we have SUCCEED. Okay, that example is already there. The possibility of me picking out an S, let's actually change the color again, of picking an S is, how many letters are there altogether? 1, 2, 3, 4, 5, 6, 7. There are 7 letters, so that is 1 over 7. The chance of me picking out a U at random, oh, not me, sorry, Sony. U, it's also, there's 1 over 7 chance. C, there's 2 over 7, right? There are 2 C's in here. Same with E. It's 2 over 7. Right, that's the probability. That's the chance. You can change it to percentages if you want to find out what that looks like. D, it's 1 over 7. So I have this same chance of me picking out an S, U, and a D when I pick one out at random. C and E also have the same chance, but they are higher. It is a higher chance than S, U, and D. Moving on. Two. Zoe buys a pizza. She's allowed 2 different toppings from mushroom, beef, pineapple, and olives. List all the possible outcomes. Example, M, B stands for mushrooms and beef. So we have 4 possible outcomes. Oh, we have not 4 possible outcomes, sorry. 4 possible toppings. We have mushroom, we have beef, we have pineapple, and we have olives. Right. Now, listing all the outcomes like this, and we're choosing 2, we can. I'll make this longer. We need to now get in the habit of drawing up tables. Now, I know that's not the cleanest and neatest table you've seen, but it'll do. It'll do. And there's an advantage of doing it like this. It's because we can see everything, and we won't miss any. We don't have to go back and think, oh, have we missed a combination out? This thoroughly goes through it systematically. Also, when it does become more and more complicated, yeah, this is definitely more helpful than us just thinking of possibilities, on our own. Cool. Now, I'm going to fill this table in first, and then we'll talk about it. Actually, no, I might talk about a little bit of it now. Okay, I'm going to write MB here. I'm not going to write BM, because MB and BM is the same thing. Beef and mushrooms and beef, that's the same thing. So I'm just gonna default to MB. Oops. Again, I'm gonna say MP rather than PM, just so this and this looks identical. Otherwise, it's just confusing. And at this moment, the order doesn't matter. In this situation, the order does not matter. In some situations, they might, but this one, no. Again, so I'm going to write BP rather than PB. I'm going to go say PO, MO, BO, PO, and OO. What was O again? Olives. Okay, cool. All right. And then here's what we do, and we should always do this for every question. Here's a really great tip. Every step of the way, go back and read the question again, just real quick. Have a quick browse to make sure if we're missing anything, and that we are indeed heading the right way. We can't just say, "Cool, I drew up a table. Look at me," and then be done with it, because that's doesn't quite answer the question. So Zoe buys a pizza. She's allowed 2 different toppings. Okay, so seeing that word underlined, right, makes me think that MM is not a possibility. Mushrooms and mushrooms is not a possibility. I'm going to have 2 different toppings. You might say, oh, she's allowed to, but she doesn't have to, right? I'm not sure. But because the underlying word is different, I'm going to say that perhaps these are not allowed. Neither is this one. If that's the case, PP and OO also not the case, right? So maybe we don't count those. Of course, if I'm wrong and we have to count them as well, then of course you cannot cross them out, but that might be an extra detail we might need. Moving on. Ooh, it's a D4. It's a 4-sided die. Okay, complete the outcome table below to show the product. The product means multiplication of the possible outcomes when the 2 4-sided die are rolled. Cool. All right, possible outcomes, again, table. Let's go table. It's 1, 2, 3, 4. 1, 2, 3, 4. I should have, no. One moment. There we go. Yes, that's not great, I see. But you know what, we can do it. All right. The product. So if I get 1 and a 1, it means I times 1 by 1. I go 1 times 1. Let's change the color real quick. It's a 1. If I get a 2 and a 1, that's 2 times 1. That's a 2. 3 times 1 is a 3. 4 times 1 is a 4. Okay, next one. 1 times 2 is a 2. What about this one here? 2 times 2, I get a 4. If I get a 2 and I get a 3, that's 2 times 3, I get a 6. 2 times 4, I get an 8. Over here, 3 times 1, I get a 3. 3 times 2, I get a 6. 3 times 3, I get a 9. 3 times 4, I get a 12. 4 times 1, I get a 4. 4 times 2, I get an 8. 4 times 3, I get a 12. And 4 times 4, I get a 16. And boom, that's question number 3. Number 4. The spin as shown below is spun twice. Complete the outcome table below to show all of the possible outcomes. Now look at that spinner real carefully. It's A, it's B, it's C, then it's B again, and it's E. So there is no, D is not there. And there are 2 B's. So let's be careful about that. So first spin, we have a grid like that. Let's see. I'm just gonna copy it and paste it. Yes, thank you. Just so we can use this instead and just draw on it, because apparently I'm not good at drawing up tables. Or so I have noticed. Okay, so let's write on this. Okay, here. Okay, possible outcomes. Here we go. I'm gonna say a possible outcome is A, B, C, and E. For the second spin, I also have the same combination, same things that could happen. Right? Cool. First spin and second spin put together. Now we're going in the middle. I can get an AA, I can get an AB, I can get an A and a C, I can get an A and an E. Oh, actually, because they say first and second, I wonder if the order matters. So let me redo that. Maybe the order does matter at this point. Maybe we do want to be careful. So the first spin is a B and second spin is an A. So let's call that BA and CA and EA. And so on and so forth. That's AB, that's BB, that's CB, and that's EB. That's an AC, BC, CC, EC. AE, BE, CE, EE. There we go. And that's the table. That's the outcome. Carrying on. B, this is B. This was A actually. I didn't say that. B, use your table to determine the probability that a letter B will be spun at least once. At least once. All right. Okay. I should have read this question before I started it. I'm going to draw up another table. Here we go. I'm gonna say A, B, C, B, E. I'm gonna write everything. Now, here, the probability that the letter B will be spun at least once changes the question a little bit. That table right above for us doesn't quite work because it doesn't take into account that B would happen twice. So I wonder if that's a flaw in the design, or I've used it in a way that the creators weren't intending me to use it. Maybe they didn't want me to actually write in the A, B, C's, and E's, and they just wanted me to start filling in immediately. Well, anyway, let's say this is the case. I have AA, I have AB. Okay, well, having seen the question, the order doesn't matter, so I'm just gonna run right through it. All right, here's the table. So let's highlight all the ones with a B in it. So the possibility that B will be spun at least once. So this one there, and there, there, ba 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 bam. There we go. So what's the probability? At least one. So we count both as well. When it's BB, we still count that. So we think about its probability. We count up all the possible, how many possibilities are there? We read this whole thing. We come up and say that's 25 possibilities. You could do 5 times 5 because that's a 5 by 5 table. So it's 25 possibilities, and out of them, how many have B in it? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there you have it. Boom. 16 over 15. That is the probability. That is the probability. Right? You could also say that's, what is it, 64%? I think. Yeah. Yep. It is also 64%. Or 0.64, of course. But there you go. There you go. 16 over 25. So that's the answer to B. Here's to C. The probability that B will not be spun at all. So it's actually the rest. It's actually the rest. The ones without B in it at all. So it's actually, and we can count it up, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 out of 25 possibilities that has no B's in it at all. Done. D. What do you notice about the answers from part 4B and part 4C? Is there a relationship? Yep, it's that C, the answer to C, is the leftovers from the question B. They are the leftovers. Or you could also say that they add up to the entire thing. They add up. If this fraction and this fraction adds up to 1, adds up to the full scope of probabilities, right? So they end up being 25 over 25 if you put them all together. And that's about it. Okay, now we are in 1C. Question 1. The probability that a certain brand of firework will not light is 1 over 8. That's okay, that's pretty bad. Okay, Mahoney buys 2 fireworks. Use this information to complete the probability tree below. Use fractions or decimals. Okay, well, they told us in fractions, so let's use fractions, shall we? Lights or fails. 2 fireworks. 1 firework lights. We know the fail probability. That's 1 over 8. So for it to light, it would be the rest. 7 out of 8, it should light. Right? Here we have 2 more. We have lights or we have fails. Again, that'll be 7 over 8. Actually, let's write that again. 1 over 8. 7 over 8. 1 over 8. Right? There we go. There we go. Now remember, the second firework doesn't depend on the first firework, so it has the same probability. 7 or 1 out of 8. Number 2. Gary has a box of pens containing 5 blue pens, 3 red pens, and 2 green pens. Gary chooses 2 pens from the box without looking. Make a probability tree on a separate sheet of paper and use the tree to list all the possible outcomes. Cool. Okay. Now, I don't think we actually need, because all the possible outcomes, they don't actually need the chance in there. But no, let's get to it anyway. There are 3 ways to start to begin with. I'm going to say blue, I'm going to say red, I'm going to say green. Okay, we can talk about the probability to begin with. How many pens are there all together? So it's 5 and 3 and 2. 5 blue, 3 red, 2 green. So all of that put together, 10 pens. So that's 5 over 10 for blue. That's 3 over 10 for red. And that's 2 over 10 for green. Cool. Now, second pen, we also have 3 possibilities. Another blue, or, oh wait, red, green. And we also have blue, red, green. Okay, I've drawn this poorly, haven't I? Already we see. Okay, here we go. All right. I should have started off with it being spread out more, the 3. Cool. So that's my second pen. We can do the probability on it. It's I don't like to. I'll start off by doing just a few. The problem is that the problem doesn't ask me for it, so I don't actually need it. I just need to say, okay, that's blue and blue. That's blue and red. That's let's say blue and green. That's with a comma in the middle, sure. They even want brackets, but you can type that in. But for me right now, I'm just going to write it without brackets. Blue and red, because red and blue and red doesn't matter at this point. Red and red, this is red and green. This is blue and green. This is red and green. This is green and green. Right? Cool. So the actual question, we've answered it right here. That this is the question they've asked. The list of all the possible outcomes, which is why I wouldn't bother with the probabilities that much. Another reason why I wouldn't really bother with it very much is the fact that because we've taken one pen out, that changes the probability a little bit. So in the case of us having taken out a blue pen, here's what happens. The chance of me getting a blue pen out again is not 5 over 10, just the same. It is actually, now there are only 9 pens left, first of all, and there are only 4 blue pens left inside. This one is, to get a red out, it would be 3 red pens left out of 9. For green, it would be 2 green pens out of 9 pens, and so on and so forth. And so it changes a little bit every time, and it's just unnecessary for this question. But just for those who are curious, that is how you would do it, and you can work out the rest. You can. The question doesn't ask for it. That's all. Okay, Hannah plays badminton and then tennis. The probability of her winning a match is shown. Complete the probability tree below. Okay, one moment. Let's just. If I don't need to actually. I don't want to actually redraw that table if I can avoid it. Okay, just a quick copy and paste. Here we go. All right, let's fill in the blanks. 9 out of 10, Hannah wins at badminton. Okay, well then what's the chance of Hannah not winning? It's the rest, isn't it? It's 1 out of 10. Right? Because 9 out of 10, wins. The rest is that she doesn't win. It's 1 out of 10. Sure, you might think, oh, but you could draw. Yeah, no, but remember, it doesn't say she loses. It says she does not win. Okay. 2 out of 5, Hannah wins at tennis. So the rest is 3 out of 5. Hannah does not win. And I assume that's the same here. That's 2 out of 5, Hannah wins. 3 out of 5, Hannah does not win. Boom. Let's make that 3. More clearly a 3. Okay, Jamal has a bag of counters. There are 6 red counters and 4 white counters. Jamal takes a counter. Now they are looking for that. So, 4 white counters. Jamal takes a counter without looking and records the color. Without putting the first one back, he takes another counter. Cool. So, what is happening here? Now, what is happening here? So we talked about this just moments ago, and I said I won't do this for this because the question doesn't ask me for it, and why would I bother? Why would we bother with things that weren't even asked? But here they are asked. So let's have a look. Okay, Jamal could get a red counter or could get a white counter, but the chances are different. So 6 and 4, there are 10 counters altogether. The chance of Jamal getting a red counter is 6 out of 10 because there are 6 red counters out of 10 counters in total. White is 4 out of 10. Okay, now let's go up in the tree this way. Let's say Jamal takes out red to begin with. The first one is red, and it is not placed back in the bag. So one red counter is now out. It's gone. So the chance of picking out another red is, first of all, it's out of 9 because one counter is gone. And it's not 6 anymore, it is out of 5 because one red counter is gone. White, however, there are 9s because one's gone, but it is still 4 because all 4 white counters are still in the bag. So it's 4 out of 9. Talking about the next one, in the case that the white counter is taken out to begin with, then we have 6 out of 9 for red because one counter is missing, but there are still 6 counters in the bag. And of course here we have 3 over 9. All right? That's because one counter is gone. So it's 9 counters in the bag altogether. So that's why we have the 9. Then we put the 3 in. 3 because there are 3 white counters left in the bag. In the bag there are 3 white counters out of 9 counters altogether. You can of course draw this or you know, you could draw it, or you could, you know, do something. Use counters if you have them. I don't actually have counters right now. But yeah. So to illustrate this is the one I will explain and you spend more time on. Of course, if you don't need it, you don't need it. But here we go. Let's say we have this in a bag. In our bag. We have white counters and we have our red counters in a bag. Cool. So in this situation, this is the first choice, isn't it? There are 6 out of 10 red counters, or there are 4 out of 10 white counters. Probability of us picking a white counter. That's the chance. Now, for this top bit here, in the case where we have gone up this path, in the chance of us having gone up this path, this changes a little bit. We have taken one red counter out. So we end up having the 4 white ones still there, but only 5 red counters left. And that's the bag. Which is why we get these probabilities here, 5 out of 9 and 4 out of 9. And of course we can think about it similarly for this part here. The path in which we have picked out a white one to begin with, which means we will have only 3 white ones to begin with, and all 6 red here, right? Which is where this one lies, where these 2 probabilities come from, this situation here. Okay, so hopefully that made sense. That is the entirety of the worksheet. And yes, still you can definitely ask me questions about any of this, but here it is. And yeah, have a lovely day. And yeah, see ya. You look good today, by the way.